Here we go. Good morning. It's getting to be a sunny morning here. This is the beginning of week 4 of our class. I guess that means that we're sort of like at about a 25%, 1/4 finished. The rest of it, I promise you, will move along more quickly than you think it's going to. For people who like keeping score, assignment 3 was due yesterday. And as of this morning, I had 11 submissions out of 18 students registered for the class. Most of them were yesterday, so much for my suggestion to get your work started early and done early. So if we look at what's coming up, we notice that February 12th is assignment 4. And you notice that these things will pretty much follow in order, and except for this, they'll follow at 1 assignment per week. So I'm going to make the pitch again. If you wait until February 11th or 12th to do assignment 4, you're probably not going to have a happy experience. It's a more involved assignment. We're going to cover some of the highlights of what you should be looking out for, but you need some time to work through it. And if you start early and if you have a question, there's plenty of time to get the questions answered. And there's also plenty of time to go back to a solution that's not working and improve it. So if you wait until Sunday to do all of that, then there's rarely that amount of time. We're going to see certain things come up again in assignment 4. The idea of being able to convert from Fahrenheit to Celsius comes up again. Most of the 11 of you who submitted your work now have working convert.py files. No need to redo them, just copy them into a new directory for assignment 4. Or do it all in the same directory, but no need to create another convert.py file. That's one of the advantages of splitting your functions into a separate file, is you can just pick them up and take them with you. So if you look on the calendar for week 4, we were supposed to be starting, I believe, module 3 on collections, and we already did that. So we're perhaps a half a week ahead of schedule. That should be the worst problem we have. It'll give us some more time to cover more things having to do with collections. And as I said last time, the 2 changes that we're going to make is we are going to cover dictionaries and tuples as part of our discussion of collections. And we're also going to blend modules 3, 4, and 5 together because they all have to do with the same topics. They have to do with collections, by which I mean data collections, iterations, which are various ways of looping through code. And lastly, in module 5, they finally put it together for collections and iterations. So that doesn't make any sense to me. We started to do them together. We'll continue to do them together. So assignment 4 is the first assignment that requires you to use the physical simulator. And it's also the first substantial programming assignment that we have in the course. They just get harder. They don't get easier. So you need to expect that, and you need to budget time for that. And you can also assume as the programs get harder that you're going to need some time to get it to work the way you want. So I will pitch once again for front-end scheduling. Get started now. And if you're done early, that's good. So one of the things I want to do today is I want to go back to the template that's both in D2L and my version of it for doing physical simulator programming with the physical simulator, and show you how lists might get involved in that kind of programming. That's kind of a major hint, hint, wink, wink for assignment 4. In assignment 4, you're really going to want to keep a list of the temperature readings through the day. And when I say list, I mean it more generally. Might be a list, it might be a tuple. But we will look at how to get those two topics of collections and the physical simulator kind of together today. Based on your, or at least some of your requests, I'm going to take some of the extra time that we have, because we're a little bit ahead, and show you how to do something not the same, but similar if you were going to use guizero. And we will use a guizero widget called a waffle, which will look a lot like the lights in the physical simulator. I don't remember if the physical simulator itself was programmed with a waffle or not. And what we'll try to do is we'll try to keep on introducing different guizero widgets until you learn how to use all the widgets that you see in the physical simulator. The not very well kept secret is the physical simulator is a guizero application, period. There's nothing going on there that can't be done in guizero. And the concepts behind guizero have a lot more applicability and longevity in your programming future than the physical simulator does. So that's part of what we want to do today, and we'll see how the time goes. We also want to start expanding our view of lists, and again, general, not necessarily a list, but the general collection, into 2 dimensions. So whenever you see something with rows and columns, whenever you see something that looks like an Excel spreadsheet with its rows and columns, think 2D. There's basically rows and columns, X's and Y's. There are 2 dimensions to it. It's very important that you learn how to deal with 2-dimensional data structures. It's just comes up a whole lot, and it is really a significant part of learning programming, and certainly a significant part of doing some of the exercises in the class. We also last time started to look at dictionaries, and what we did was pretty simple. It's time to take that concept and expand it. So what we're going to do is we're going to consider dictionaries, which we know have to have keys. And now we're going to make the values into data collections. And we'll do that in 2 different ways. In one way, the data collections will all be numbers, and in the other way, it's going to be a mix of strings, integers, and floats. So once we get the idea of how to use a dictionary that way, then some of these assignments are going to make a lot more sense and be done a lot more easily. There's usually a workaround, but it's not always pretty. So let's go over to PyCharm. And just to share with you what I do when you submit program exercises, I create directories for everybody and then start putting your code into them. So everything that you submit from here on out is going to get looked at in PyCharm, which is why please do not give me screenshots of code. I can't do anything with them. So that lets me run these things in PyCharm and see how they work, make comments about improvements. So that's what's going on there. Let's review what we did last time. I'm pretty sure that was in this directory, data collection demos, and we've got 2 of them in there so far. The simpler one is the list. So let's call that up and let's review what was in there. And if at any point you have questions, especially now that we're looking at this the second time, and hopefully you've looked at this or something similar since then to make sure you understand the concepts here. One simple thing I'd like to point out, PyCharm decided to print these doc strings in italics, And that means that this character over here that looks like a divided by is not, it's the bar that's the shift above the enter key. So to make them work right, make sure you use that shifted key above the enter key, not the divided by. We found out in doing this, since this is a very typical list, a list of grades, and we want an average, that if we look at the statistics module and import a function called mean, we don't have to sum and divide. And I'm all in favor of that. Any module that I can find in Python, or any module that I can find in the outside world that I have reason to trust, I'm going to do that versus writing my own code. Some of it is because I'm lazy. Some of it is because I'm an engineering kind of personality who just wants to get the job done. I don't think it's necessary for me to write a mean function if one's available. Not only is it available from statistics, it's available from some other modules, but this is probably the easiest one to use. So if you're concerned about taking up a lot of memory with your program, and you have the feeling that statistics might be a big module, then just import what you need. And if you need more than one thing, you can comma separate what you need. If you're not concerned, you can just say import asterisk. So we started this from a template, and the template, had a header, a better one than this. It had a main function defined. And the reason for defining that main function is to give us a place to put our stuff. So all of our stuff gets nicely indented under main until we need other functions, and then things get a little more complicated. But if it's a simple program, maybe up to 20 lines long, putting it in a main function is nice and orderly. It also lets us use this cryptic looking thing at the bottom to execute the main function. And if we follow this from a template, we don't have to think about it, and we know it gives us a little green arrow over here, which is good. So what do we have here? We have a list. How do I make a list? I use square brackets, and I can either create an empty list with empty square brackets, or I can put things in the list by comma separating. Turns out that it is not important in Python that the things in the list be the same type of variable. So I can mix integers and floats and strings, and it just has to make sense. You also see that PyCharm loves to give you color clues. So this kind of pale reddish clue means that it's a variable being defined. The greenish clues means it's the same variable being used. So we have defined, and if I hover over this, it says, you have defined a list. The list is composed of ints and floats. And by the way, here are the values. So you should know that PyCharm will give you that information if you're concerned about what's going on with a variable. And if you use doc strings, you can also get some information by hovering over the names of the modules that you're commenting. So we're using comments, and if they're a single line comment, I recommend putting them above what's being commented. No space between what's being commented and the line itself. I made that exception here because I'm going to do several things. I'm going to print all grades, the highest grade, the lowest grade, the average grade. So then I'm going to skip a space and do each one without skipping any spaces in the section. So critical line here. We already talked about the data collection, which is a list. Now we're going to talk about the iteration. So this is one way of iterating anything in Python that is iterable, not irritable like me, but iterable. And what kinds of things are iterable? Well, obviously, lists dictionaries, tuples, and sets, and even strings are iterable. So the simplest way to iterate them is to say, for any old name you like Frog, Bill, in anything that is iterable. Now, if you're like me, and you like things very orderly, if you name your container, data container, in a plural, then you can say for singular in the plural. So for grade in grades. And I think it's hard to not understand what's going on there. We're going to go through each grade in a list of grades or some kind of a collection of grades. The restrictions to doing this is that it has to start at the beginning and it has to hit every item and it stops at the end. So line 16 is the way to go if it meets that criteria. If it doesn't meet that criteria, we have alternatives. And the alternatives are using indexes or indices to access things. As we saw last time in the cheat sheet, anytime we have lists and tuples, we have a concept of an index. Dictionaries and sets, not so much. So these indexes are integers and they always start at 0. If you think about it for a minute, you'll figure out that the index of the last element, since we start at 0, is the length of the list minus 1. So we have 6 items here, 0 through 5. Don't forget that this starts at 0. And don't ask for index number 6 because you'll get an error. But don't worry about indexes if you're going to start at the beginning and hit every one and stop at the end. Just do this. So we found out if we want to print them horizontally, we have to tell the print statement, just put a space after each time you print. And when you get done, go to the next line. Questions either about what's going on line 10 or what's going on line 16. If you, oh, and I bet I can hit the control key. I can't. Okay. If you understand what's going on lines 10 and 16, you're headed in the right direction. If not,
I have a question about line 16.
Go for it.
So how does it know what grade is referring to if it's not defined higher up in the code?
So remember that this is an iteration structure. So what it does is behind your back, it starts at index 0, and then it does index 1, 2, 3, 4, 5, and then it's smart enough to stop.
Okay.
So this loop, and the loop is only two lines long. This loop executes 6 times. The
Gotcha.
first time,
Okay.
grade has a value of 86. The next time it has 90.5. This variable, notice the only color matches between 16 and 17.
Right.
That variable is unknown outside of the loop, even if you try to define it again. This version of the variable is within inside the loop. And if you want to call it dog, go ahead and call it dog. I don't care. I would not particularly like you to call it I, because that implies an index, which it's not. The index is being hidden from you. Does that help? Are we good? I guess we are. So given that, the remaining tasks are to calculate highest, lowest, and average. Well, I have a list. Am I interested in writing my own max function? I am not. It's there on the cheat sheet. It works fine. It will take any kind of a data collection and return the maximum value as long as you haven't mixed up things like numbers and strings. If you've mixed up numbers and strings, max is not going to work that well. Same thing with min. That's all I need to do. Now, the average, the only reason that mean works is because I imported it over here. Python right out of the box does not include that mean function. It's inside the statistics. So the import is necessary to write mean. I just pass it a data collection and it does it. And then we spoke about the fact that we don't want as many decimal places as math might require. So we do this formatting over here. How do we do that? We use an F over here. We use quotes for the string. Then when we get to something that needs to be evaluated, we use curly braces. And then when we have something that needs to be formatted, after the thing that's going to get evaluated, we put a colon and then some valid format specifier. All right, so that's what we got going on there. Let's move on to the dictionary, unless there are any questions. Okay. So, fundamental thing to understand about dictionaries is that the entries in the dictionary are key value pairs. The keys must be unique. The values don't have to be unique. The keys can be anything you want, but are usually consistent. So they're usually either integers or strings. Values can be whatever you want. So here we said, more important, or as importantly as knowing the grades, is knowing who got those grades. So we built a dictionary that includes the student ID number along with the grade in this particular exercise. So 701 got an 86, 705 got a 90. Who's behind these numbers? Well, we'll figure out that later. So am I going to iterate through a collection, a data collection? I am, 4 in. But now that I have a dictionary, I've got 3 choices. I can iterate through keys, I can iterate through values, or I can iterate through items, which are the key and the value. So if items is going to do a key and a value, then I better have 2 things here to receive them. And this, you might remember, is a tuple because it's a comma-separated list of things. And now that I've separated items into 2 pieces, I can print them separately. Here, when I do max, min, mean, I only want to deal with the values. The values are simple integers or floats. So I just say grades dot values and take the max of what that returns. And that's it. Questions? We're good? I lost my piece of paper. Oh no, what did I do with my piece of paper? Hold on. There we go. Okay, so with assignment 4 coming up, I think it's time to learn how to deal with the physical simulator. Even if I don't like it, I think it's time to do it. So let's create a new folder here. And I'm going to use this just to store the work that I want to do with you today. So I will call it 30 January 23. And I'm going to decide that we're going to do something with the physical simulator. Now, rather than starting from the beginning, although I can certainly go back to D2L, I'm going to find the template that I wrote because I like it. That's why I wrote it. And I'm going to make a copy of this template. So we're going to go right click and say copy. We're going to go in today's work folder and say paste. And we're going to give this some reasonable name, like physical simulator demo 1. That's a reasonable name. Doesn't say what it does, but it does say it's a demo. And I'm going to let PyCharm open it up in the editor. So there is my template. There's no reason for me to rewrite this template each time. There is a reason for me to make this up to date with what's going on. So today is the 30th of 2023, and this is a physical simulator demo 1, and it has we're going to play with the lights. I'm going to keep the imports there. I must do line 8. I might want to do line 9. But remember down here, do not use time in a guizero program. So keep that in the back of your mind. I'll even keep the comment here. Typically, we do a line like 13. This is actually a way of creating a sensor object for our program. It lets us talk to the simulator. And then down here was just some code that said, turn the red LED on, wait 2 seconds and turn it off. Well, that's similar to what we're going to do. So let's leave those lines there for the time being. And let's say that we want to turn all 4 lights on, wait 2 seconds or 1 second, and then turn all 4 lights off. So bad news is to write this 4 times over. That's just not the way we want to deal with a program. If we want to do this 4 times, we want to set up some kind of iteration, which means we need something iterable, and let the computer do the looping for us. Well, where's a fundamental problem when you start working on these programs is, where's your physical simulator? Well, it's not here. And if I run this program, it's going to tell me I can't talk to the physical simulators, so you lose. What I need to do, the easiest thing to do, is go down to the terminal window down here, which will open up a terminal, and type PPS_GUI. Notice it's an underscore, not a dash. When you hit enter, if you don't get this, then your installation is not correct. And that needs to be fixed like last week, certainly this week. If you can't get this to come up correctly when you go to the terminal and type PPS_GUI, something is really wrong, and you're not going to get very far through these exercises. While you're doing this, just don't close this, just leave it open. It's tempting to X out of it, and then you just have to go back and start it again. So we'll leave that there. We're just going to look at the lights today. So we'll put that there. And we notice either we're going to make a good guess, or we're going to go back to the simulator cheat sheet and find out that the names of those 4 circles, the names of the widgets, are RLED, YLED, etc. And that's what I want to loop through. So let's make a list. And the name of the list might be lights, L-I-G-H-T-S. Notice I'm going for the plural. And I'm going to make a list of the names of the widgets as strings. GLED. And the order in which I put these is going to be important. So we've got that. What do we have? Do we have a list? No. Let's hover over this. What we have is a tuple. It's a tuple of strings. The tuple does not know anything about the simulator. It doesn't know that it's the names of widgets. All it knows is there are 4 strings here. So now we've got a connection to the sensor. We've got an iterable, and we can write a loop. And now that I named it plural, I can say for light in lights. And I know that since this is a code container, it ends in a colon, and everything that I want in my code container needs to be indented. So the indentation forms a container. The container is indented inside of main. And right now the container has 3 lines in it. Well, all this does is it turns the red LED on, waits 2 seconds and turns the red LED off. That's boring. And I created this snazzy variable over here for my loop called light, and I never used it. And PyCharm knows that. So if I hover over it, it'll say, the variable is not used. And it has a very interesting suggestion. The suggestion is, do you want to replace it with an underscore? Why would I do that? It turns out that underscore is a legitimate variable name, and it's taken to mean I needed to define this variable, but I'm not going to use it. So I can't leave it out. But if I'm not going to use it, I could replace it with an underscore. And that's kind of a cool thing to do. It's a little show-offy that you know that that's how things work. So I don't want to turn the red LED on. I want to turn on the LED that comes from evaluating for light and lights. And that's the same LED that I want to turn off. So the idea of a loop is that this loop variable comes in handy. It's there for a reason. It's there to keep us from writing this same code 4 times. And if you look up the physical simulator cheat sheet, you'll find out that sensor.output, if I want to refer to the light, I must pass one of these 4 strings, and then I must pass another string that says on or off. So let's see what happens here if we run this. A little convenience in the newer versions of PyCharm. If you look here, there's a choice for current file. And if you run after selecting that, it'll run whatever file is highlighted up here. Save you a little bit of effort. Okay, red, yellow, green, blue. A little boring because it took too long. Let's make this 1 second, run it again, and now it's a little less boring. Okay, so that's how we combine the concept of a data collection, in this case a tuple, with an iteration. Key concept really is a key concept. If there's something you're not happy about with what's going on in lines 15 and 17, now would be a great time to ask. A great time for me to take a sip of seltzer.
So if I'm understanding it right, having the lights before our tuple there makes it so that everything beneath it just runs what's in lights.
Well, lights is a data collection. It's not executable.
Right.
It's a collection. It happens to be iterable. And when I write line 17, it says 1 iteration at a time, iterate through the tuple.
Okay.
So the iteration on line 17 will execute 4 times.
Right.
And will take on those values. And I guess I can illustrate, I can't add another one, but I could certainly take one out, run the program again, and now the iteration is red, yellow, green, done.
Right. Cool. Okay, thank you.
Okay. And in writing this, it's a good assumption that I'm going to use this variable inside of the iteration. Okay. Other questions? Why didn't I make this a list? And the answer is because I'm lazy and I didn't want to bother with the square brackets. I didn't even want to bother with the parentheses. And I'm never going to change the content of the list while this program is running. So that's what a tuple is about. You hear tuple, you think immutable, can't be changed, doesn't have to be changed. So I'll leave that out. If you're really lazy and you're curious, I can do this a different way. Lights 1 equals R LED, Y LED, G LED, B LED. What is that? It's a string, right? There's only one string there on line 16. I want to take that string and I want to split it based on spaces. And if I hover over this, it says you have a list created. I'm going to create this as a list of strings. So split automatically creates a list. I don't need the individual quotes. And if I do this, the program should work just exactly the same way. So do I care? No. I think line 16 is cute. It shows that you know how to use dot split. If that doesn't do anything for you, don't worry about it. We'll find other uses for dot split. Okay. Program it does what it's supposed to do, but it's all over in 4 seconds, right? And please remember, when we make this into a guizero program, we're not going to do this. That's critically important. Well, what about if we want this thing to go forever? So after it gets done doing it, we want to do it again. And after that, we want to do it again. And we want to do it essentially forever. Well, we need an iterative structure, but we need an iterative structure that can go on forever, and that's while. While normally goes on for a condition, but if that condition is forever, we just say while true. It is a container, so it ends in a colon, and PyCharm says, what are you doing? There's nothing in your container, and that's because this needs to be indented. So the outside container is the main function. Then we have an inside container that's a while statement. The condition is true, which is always true. And then under that, we have an indentation of the code. So notice that before, 4 seconds after we started it, the program stopped with process finished with exit code 0. So what's going to happen now? It's going to do an iteration, and then it's going to do an iteration, and then it's going to do an iteration. The program does not stop. The program is still running because while true is never false. So that's another important concept that's much more valuable in the simulator than actually it's not a viable concept in guizero. It won't work, as will the sleep not work. So we're going to have to rethink things a little bit when we get over there, which we will shortly. So something that wants to go forever, that's how to do it, while true. Remember that in Python, true is spelled with a capital T, false is spelled with a capital F. Not so in most other languages, including Java. Question about what we've done, why we've done what we're seeing. Notice that we just keep on indenting things. You know, PyCharm, if we let it, will keep track of this indentation for us and do the right thing. Well, how do I stop the program? Not by stopping the simulator. That won't work. The simulator was run separately. It keeps running. So I have a choice. I can hit the red stop button over here, and that will stop the program. And by the way, it says this program was interrupted while it was doing a sleep. Side question. I'll claim that if you do this 100 times, that it's always going to stop at line 20. It's always going to be interrupted at line 20. Why do you think that is? Do you care? What does this program spend most of its time doing? Just like me.
I'm guessing because it's going to sleep at
Yeah.
line 20.
This program spends most of its time sleeping. It doesn't take that long to execute the commands in the loop.
Mhm.
It does take a second to execute this, which is an eternity for the program. And that's why you can't use it in guizero. So when you interrupt this program, you are 99.99999% likely to interrupt it at line 20. And that's fine. That works. The other option is go here back to this and make the program fancier and have the program stop on either one of these push buttons, or what might work better is this thing that is not exactly a push button. So notice the push buttons push as long as you click them. This, when you click it, actually goes to a different state and it stays there. So think of this as on, off, or off, on, it doesn't matter. But that makes the program a little fancier. So that's the other way to do it. Okay. Questions before we put this one aside? Okay. So for those of you who asked, this one's for you. We're going to do this we're going to do something similar in guizero, only because to do exactly this is a little tricky. Not that we can't do it, but it's a little tricky. So let's close this and let's go to our guizero template. How are we doing with time? All right, I'll take my 20 minutes or so. Let's go to our guizero template and copy it. And let's put it in today's work folder. And let's call it the guizero waffle demo 1. And there it is. So clearly, we're not running the physical simulator. That's not how this works. Demo of waffle widget. Okay. In general, guizero is a small library. You might as well import everything from it. The text, I'm going to keep that line in there, but I'm going to call the text lights, GHTS. And now I'm going to build a waffle widget that needs a name. And my style of naming widgets, aside from APP, well, sort of kind of including APP, is 3 letters describing the widget, an underscore, and what it does. So this is going to be a waffle widget to show things that look like lights. Now, just like line 12 and line 14, when I want to build a guizero thing, it starts with a capital letter and it shows up as being part of guizero. And just like line 14, I need to put this someplace. And the only place to put it is in a GUI container called APP, lowercase APP. And now we discover everything that you need to know about waffles. And if you don't like my discovery method, then look up the guizero tutorial in Google, and it will tell you all of the things you can do when you build a waffle. I want to make it look like the simulator, and that means that the width of the waffle is 1, not 1 pixel, but 1 cell. The height is going to be 4. I want to make, well, I can show you this now. And I'll just do one more. The color is going to be black, which is the initial color. Okay. So if I run the current file, there you go. Now it looks like a very primitive, slightly screwed up version of the physical simulator. The title is now guizero. Here's the text, and here's a waffle. All right. If I made it two-dimensional, it would look really like a waffle. So I can make it 4x4 and it would look like a waffle. Now, if I want to stop the program, I can hit the stop button here, but I can also just X out of the window and the program stops. So what's wrong with this waffle? Well, there's supposed to be lights. So we need to take the squares and make them into circles. And we do that with a parameter called dotty. I have no idea why they called it dotty other than it's dot-like. And that will be set to true. So dotty will be true. And I want to make these things a little bigger. So I'm going to set their dimension to 80 pixels. I want some space in between them called padding. I will set that to 30. And that's all I need to do. So now what do I have? Oh, lights isn't very big, is it? That really should be a bigger text size. But the rest of it is okay. The window is too wide, but it's about the right height. I can fix it, but I don't need to do that now. But I would like lights to be bigger. And if I want all my text to be bigger, I just say in this APP window, set the text size to maybe 18 point. And now it's bigger. Hello. And it's also stuck at the top. Can I move this over? Yeah, there you go. All right. So now I have something usable. And all I have is a layout. So that's what, that's why you pay big bucks for the physical simulator, because somebody did the layout for you. If you're going to use guizero, you have to do the layout. And that's always the first, after you design what you want to do. And I like doing that in pencil and paper. Then you need to create a layout. And this is a good template for creating a layout. But it doesn't do anything. So that's a problem. So let's get back to the idea of a list. As you see, the waffle has 4 cells in it. The width of the thing, or the X dimension, is 1, and the Y dimension of the thing is 4. Now we're going to have to deal with the indexes, but for right now, let's just think of this as 1x4, because that's right over here. And we would like some colors to appear in there. So let's create something called colors. And I guess I'll do it the way you probably like better, by putting quotes in here. So red, and these are not names of widgets anymore. These are colors known to guizero, because guizero uses another library called tkinter, and tkinter knows all about these colors. Notice I put it in caps. That's not a requirement, but it's convention in Python that says if your variable name is all in caps, it's inferred or implied that you're not going to change it. Now, the fact that it's a tuple means I can't change it, but that's all consistent. So colors in caps is a tuple composed of 4 strings. Here's the value. All right. So what good is that? Well, I want to turn the lights on. And here's a fundamental issue. The issue is that this program executes down to here. When it hits line 22, behind your back, guizero takes over a loop that you don't see and you can't directly control until you stop the program. That means that these lines of code never get executed again. It also means that the lines of code under line 22 never get executed until guizero stops the display. You end the display, close the display rather. That means that we are the proverbial SOL about getting things to execute on demand and execute repeatedly. So we need to solve that problem. And we do it by writing a function because we like functions. And the name of this function is going to be something descriptive, like lights underscore on. And how do we know it's a function? We know it's a function because it starts, we know we're defining a function because it starts with DEF, it has a name, it has parentheses, it has a colon. If I want to come back later to finish this, I can just write pass in here right now, and it will be happy. So what about if down here, I say I want to run lights on? Well, now it comes up in my list of things to do. As long as I do it above line 25, it will execute. Now it shows up in a legit color. Okay, so what are we going to do here? Well, we're going to do an iteration. But it turns out that I can iterate through these. But how am I going to say which waffle I want to light with the color? So I got to go back to the old-fashioned way of doing it, which is for some value like I in some list of integers generated by the range function. And I'm going to pass to that function the integer 4. And then I'm going to find out what in the world is going on here by printing the value of I. So nothing's going to happen in guizero, but when I execute the function, it will print the value of I. And what do we see? 0, 1, 2, 3. Well, as we've discussed, programs and programmers like to start with 0. And if we're going to have 4 iterations, then the last value generated by range is 3. Now, you will observe that 0 through 3 is 4 iterations. But this is a good thing. Having this 0 to 3 is a good thing. And it's a good thing because I need this integer to talk to the waffle. And we're getting close to a break. I promise not to wear you and me into the ground here. We'll take a break around 10. Okay, so the point here is to get the waffle to turn on with these colors in position 0, 1, 2, 3. To do that, I need the name of the waffle, and I need square brackets. And the square brackets are there to specify not only an index, but a pair of indexes. And the first value is the X value. And now we're back to being 0-based. So there is only one X, right? It's the one column, it's the width. So that's going to be 0. Anybody want to go out on a limb and guess what the Y value is going to be? If you do, you really understand what's going on with the loop.
I'm guessing for the, go ahead.
Who's up first?
I just assume it's going to be a 3.
Okay, any dissenters?
Is it gonna
It's gonna
be
be 0, 1, 2, 3, based on whichever cell you're trying to impact first.
Right.
Yeah, and where am I going to get that value?
from the printed I that we did previously?
Well, from the variable I.
Right, right.
So let me just put an I in here. And that says, go address the cell that's in column 0, row I, where both of them are 0-based. So the first 0 is the X location, the I is the Y location. But it's not so much that I want to modify the widget. I don't. What I want to do is I want to set the color of the widget. Well, what do I want to set the color of the widget to? Well, how about colors? Which one? Which one do I want to choose? And after we do this, maybe you'll appreciate how cool the physical simulator is. You don't have to worry about this. So let's ask the question a different way. The first time through the loop, what color do I want to choose? The name of the color.
So we could start with red.
Yeah, that's a good one. What about the second time?
Yellow.
Yeah, third time, green, fourth time, blue. How do I get it to pick the right color based on where we are in the loop? Going once, going twice.
I think you could assign a color to one of the I values.
Well, you've got a little backwards. Use I to choose the color. And then take whatever you just chose and assign it. Again, it's just an assignment statement. Do what you need to do here, which is choose a value from the list based on I. Use it to modify, in this case, what's on the left side, which is the color of the waffle at 0, I index. So now's time to find out if we have done something good or not. So we'll run this. Sometimes it helps to keep your fingers crossed. Where did my window go? If we were in a face-to-face class, at this point, I'd ask for applause. That doesn't work well on Zoom, but what have we got? Well, we've got a function that turns everything on. How does it do it? Well, it takes a little more effort than it does in the simulator. We have a list of colors. Let's move this over. We have a list of colors. We call a function. The function says, use the old-fashioned kind of for loop for an index, create an index based on the function range, pass that function the integer 4. We know that range 4 generates 4 integers, 0, 1, 2, 3. Call that I. What are we going to do with the I? Well, we're going to use it twice. We're going to use it to address the cell in the waffle, and we're going to use it to address the position in the color tuple. And there we go. Okay. So, questions?
Can you go over line 16 again? I'm confused on the waffle lights and then the brackets.
Sure, and it's, this is all kind of like new concepts, but someplace out there in this class is at least one person that said they want to learn about guizero early. So that's what we're doing. Let's click on this. WAF_lights is the name of a widget. What kind of widget? A waffle widget. Well, what do we know about the waffle widget? We know it's 1x4, there's circles, 80 pixel diameter, 30 padding, and the default color is black. It has a name. I can refer to all of the colors by leaving out the index. If I want to get to a particular cell, I must give it an index. And the index must be in square brackets, not because it's a list. That's a little tricky, but anyway. The index has to be in square brackets. It must include a valid X value and a valid Y value. Both of those values are 0 based. So since there's only one X one column, then that will be a 0. The Y values we want to change based on I. And we don't want to modify the widget. We want to set the color property of this individual cell to colors and then square brackets I. So just like we've always done in assignments, figure out what needs to be done on the right. It says get the string at the I position out of colors. Then assign it the thing on the left, and thing has now become complicated. So thing says, referring to WAF underscore lights, go to this index and change the color property. All of this is explained in the guizero tutorial page. So, there are no secrets here. Is the program still running? Yes, it is. Are the lights still changing? No, they're not. This happened once, and it's never going to happen again. And that makes this a little boring. And we will fix that boring after the break. But first, questions on this program. There's an important question you should be asking. How is this program structurally different than your Fahrenheit Celsius programs or your kilogram pounds programs? There's something structurally very different about this.
It doesn't use a convert file.
True. And because it doesn't use a convert file, the function sits inside of this file. Does that raise a question? Maybe not. Maybe we need a break. Okay, we can do it the exciting way. So I learned this technique from my physics teacher in college. We had him for lecture and there was a break. And I noticed what he was doing is he always got to the break and ended in a question. And that kind of encouraged students to actually come back after the break, because of course we were face to face, and find out the answer, assuming you were interested. So the question is, what is unusual and different about where lights on is defined? It's not defined like we did when we wrote our first kilograms to pounds or whatever it is. So we will discuss that after the break. I've chewed up a little bit of time into the break. We're not going to have time for a breakout session today, boo-hoo, but we will do one on Wednesday, and I already know what I want to do for that breakout on Wednesday. So let's take some credit for having worked pretty hard before the break, seen a lot of new concepts. So we will take our break till 10:15. And at 10:15, we're going to find out what's unusual about where we put lights on, why we did it, and how we're going to get some action in here. This thing is still pretty darn static. Something happened, but then the world got boring. And we don't write GUIs to have a boring world. We write them to have an exciting world. So we will do that. We'll have plenty of time to do that. And then maybe get started with a discussion of 2D lists. Maybe not, maybe next time. All right, so okay, we're back. All right, so we created this waffle that looks not unlike the 4 lights that you see in the simulator. Put a title on top of it, not unlike in the simulator. And we were looking at this function that we wrote. I'm just going to close this. It's all distracting. Looking at this function, the difference is between the way we did it with the pounds to kilograms is that this function was written up here. And we passed to the function the information that it needed to do the conversion, and it returned it. So that all worked out quite well. Well, in guizero, we kind of have an issue, and we've touched on it already. And the issue is that variables are only defined within the functions. Variables are only valid within the functions in which they're defined. So what does that have to do with this? It has to do with the only widget that we care about, which is this one. So if it was defined over here, that means that it's defined within the main function. And since this function is an inner function or defined inside of it, we can see that we automatically can use and recognize, modify and change our widgets within this function because it's an inner function. If we moved it up here, it wouldn't know what that is. And there are ways around it, but it's not quite as pretty. So that's the story. Okay. So what I'd like, well, first of all, could somebody just give me a shout out that I'm really talking and you can hear me?
Yes, you are.
Okay.
Yep, copy.
Just checking. Let's say that we have a clue that we want to write a different function, similar. The name of this function is going to be lights off. The range is the same, except the color is now going to go to black. That's what it means to shut the lights off. Okay. This function is called, you can see it's yellow. This one isn't, it's in gray. Where was this called? Well, it was called down here. As a matter of fact, I have to try something. Yeah, something cool. I just learned actually in doing Android stuff. It's a PyCharm. Well, no, it's a JetBrains thing. If you hold down the control key and hover over something and click it, it will take you to the other place where that was mentioned. So this isn't a very big program. We didn't need to do that, but it works. Well, that's an interesting call, but I can't take it right now. So what good is this function? Well, we want to have the lights blinking, but how are we going to turn them off? So after we turn them on, let's say that we're going to go to sleep for a second. Can we do that? Yes, no, maybe?
Maybe, but once again, you don't want to use it in.
Right, we
Oh,
can't.
I've tried doing the sleep for 1 second and it just kills the program.
Absolutely. So bad idea. And the reason is because sleep really does kill the program. Well, what's the implication of that? This monitoring of your program by guizero doesn't happen. So that was a very, very painful lesson to learn when we first started doing this. So that doesn't work. But fortunately, we have two options to make it right. There are two functions. One is called after and the other is called repeat. And they need to be attached to something. And I don't think it matters what they're attached to. So I always attach it to APP. So I'm going to do app.after. And of course, I can go to my guizero tutorial and learn more about it. It takes, the intent here is to say, I want to do something after a certain number of milliseconds. So that's what it's talking about, time. So we're going to put 1,000 in there. And then it says, okay, what do you want me to do after a second? I want you to run a function. What function? Well, lights off. And PyCharm will help you. Except in this case, PyCharm has now screwed this up because this calls the function immediately when line 17 gets executed. That's not what you want to do. This is what you want to do. This says, 1 second after you execute line 17,
Mhm.
execute the function lights off. So it is a delayed execution of this function, and you specify the name of the function, not the function in parentheses. This calls a function. This, the right word is it registers the function as an event handler for app.after. So if for any reason you believe me, that means I can come down here. I can do this, and I can register the function lights on. Don't click on this or take the parentheses out if you do. And what have I formed here? After 1 second, do this. After 1 second, do that. Kind of looks like a loop, doesn't it?
Mhm.
Yeah. So this is a loop. Does it do what the other one did? Not exactly, but let's see what it does do. Okay, they all go on and off, on for a second, off for a second.
Mhm.
And that's as good as we can do easily. The idea of having each one come on for a second, one after each other, is trickier, and there's no reason to make this more complicated than it need be. So takeaways from this program, and we're just about done with it. If I have functions that depend on my guizero widgets, your life is much simpler if you define them as inside functions or inner functions.
Mhm.
It helps you identify things like WAF lights and APP. Defining a function never runs the function. So these functions don't run until somebody says run the function. Well, lights on, we told it to run the function before we did app.display.
Mhm.
Now, fortunately, this function says after a second, go run this function. And this function says after a second, go run that function. So we've built a loop with a delay without using sleep. And if you look at this program in Task Manager, it's taking up very little time, but it's never, your program is never sleeping. The sleeping's kind of going on behind your back here. And it's not really sleeping either. That's not the right way to say it. What's going on behind your back is that guizero is listening for events. And this is the first event we've talked about. After event, app.after. There's an app.repeat. And those things are all time-based events. There are also push button events, toggle events, keyboard events, lots of different events, all of which are discussed in the guizero tutorial. But if you're looking for time-based things, forget about sleep and think about app.repeat or app.after. If you made this app repeat, bad things happen, because every time you execute it again, it sets up another repeat, and eventually your program blows up with a memory leak. So you really want to do this after a second, do this after a second, not repeat. Trust me, repeat doesn't work. Okay, so that's the story. So this is the first of intro to guizero discussions that we'll have. The reason for doing it is because once you get the flavor of what's going on here, you should be able to wander into the guizero tutorial and explore on your own. I say there are no secrets here. It all comes from the guizero tutorial. I would bookmark it. So that's my suggestion. And if you want to learn about different things, just go back to the simulator and let's see what we got. We have things that look like waffles. These are definitely push buttons. These are definitely sliders. This is, I don't remember, I think this is a funky, I don't remember. I think it's a picture widget. But but I don't remember then what causes this. No connection to client. Well, okay, that's true. So this knows that there's no program running against this. And this is just a picture, and it's a programmable buzzer that is the source of umpteen aggravations, and plus it's super annoying. So if you want to explore push buttons and sliders on your own in guizero, that would be a great thing to do. Okay, so so let's put an end to, well, any questions on what we've done here? You know, it's tricky. This is not easy programming. Anytime you start talking about event-driven programs, which is what this is, life gets complicated. But once you're done, now your program is alive. And it's also alive without any other intervention. So I don't do anything to make this run other than start it. And it will run forever until it's killed, either here or in the red box up there. So time-based event handling, dot after and dot repeat. Okay, all right. So we definitely do not have it. Nah, we're not going to do the breakout room today. Let's take some time and talk about 2D lists. Can I start it with a number? I guess I can. And this is just going to be a regular old Python program. So we could go back to a template, but we could also just do this. So what did we do here? Let's go back and look at this program. We created a list of grades. And it's not very interesting because it's only one measure, you know, one exam or one homework assignment. And it's for, I'm sorry, start again. Yeah, it's either a homework assignment for a bunch of students or for one student, a bunch of assignments. Not so interesting. What we really want to do is, let's say that we want to deal with a bunch of students who have a bunch of assignments. Well, all of a sudden it begins to look like a spreadsheet, which means it begins to look like a 2D list. Let's see what we can do about this. So we can define grades. And it's going to be a list, although it could have been a tuple, because we're not going to change them. And here are the grades for our first student. 86, 95, 80.5, and whatever, 85. Well, that's my first student. Well, what about my second student? Well, here's the grades for the second student. 88, 90.5, 87, 85.5. So you can see where this is going. I can create comma-separated lists. And what have I created? I've created a list of lists. Does PyCharm agree? Let's go over here and says, you've created a list of lists. Your inner list, I see ints and floats. So that's cool. We can kind of help ourselves visually by hitting enter here. And if we do, it begins to look two-dimensional. So if I do it like this, PyCharm will line things up nicely. That student's going to have problems. And what happened here? Oh, I know what happened here. That's not a problem. Finish that part up. Okay, so if I do it that way, I begin to see rows and columns visually. Does Python care? Not really. There are no 2D things. Memory is basically a list of memory locations starting at 0 and going to as much memory as you have. So anything that is broken down into lists or lists of lists are things that are managed and understood by Python or Java or whatever. But if I do this, it creates a pretty interesting visual. The only problem with this, quite frankly, is that since it's simply a list of lists, I don't know what student got those grades, and I don't know the exam either, but we can fix that problem next time. Well, as before, let's say that our first task is going to be to print all the grades. Okay, I know how to do that. For grade in grades, print grade. That's pretty straightforward. And it wants an extra space. Oh, a comment while I'm here. PyCharm has opinions about everything, kind of like me. It has opinions about blank lines. It has opinions about spelling. It actually has opinions about grammar. It has lots of opinions about PEP8. If you just follow the suggestions, your code will look better. And if you are lucky, you will get a green check mark up here. Of course, I'm being sarcastic. It's not luck. It's following through with the suggestions. So please do that when you're working on your programs, and you'll find out you have more readable code. If you have things up here on red, then please is not the right word. It's fix it. There's no point in giving me code that has errors in it because I can't run it. Unless you're really stuck, in which case we should talk. But I mean, if you have to submit it, I will comment and grade accordingly that the program can't be run. All right, so if I like this current file thing up here, I can use it. And let's see what we got. Well, we've got 3 lists. So that's what grade is. Each grade is a list. And that's not as pretty as we had hoped for. So let's take a slightly different approach to this. And I'm gonna go back and take an index approach to it. So for I in range, and the reason this is parentheses because range is a function and it needs an index. So how many rows do we have? I see 3 rows. But what about my columns? Okay, go back and change your mind later. How many columns do we have? Well, we have 4 columns. And what would I like to print? I'd like to print grades using 2 indexes. Like that. Let's run it first, talk about it second. Well, that worked really well, didn't it? There we go. All right, so new concept. And the concept, which is very powerful and very important, is called nested loops. a loop inside of a loop. How do I know the loop's inside of a loop? Because there's an indentation. Where is line 9? Inside line 9 is inside the inside loop that's inside the outside loop. And if that's too much wordful, then just look at the indentation. Do we want to make this maybe perhaps a little more readable? Maybe we do. Maybe we want to call 3 is actually the row and 4 is actually the column. And if I get it wrong, well, let's just get it wrong this way. Darn. So that's an easy enough mistake to make. If I get it wrong that way, I'm going to get an error. Basically says, no, this is 3 by 4, not 4 by 3. There's an index out of range. So when you're testing these things, it's probably better to make a different number of rows and columns to make sure that you have all of your things in the right place. So important concepts here. This will quickly inner scan columns. So it's going to cross here quickly, and then when it's done, it goes down to the next row. So this is an inner or quick loop. This is an outer or slow loop. Okay, so what do you think? Questions? Make sense? Doesn't make sense? Thumbs up, thumbs down.
Good here.
Okay, we got one okay. If I don't hear any questions, I just keep going. Alrighty. So we've got that going on. While we're here, why don't we give it another try? Right? Nothing ventured, nothing gained. For this is the row. Well, we've done this already, haven't we? Okay, so now that we're here, we've got a row. For grade in, well, how many things are in the row? Well, I would say LEN is how many objects are in that row. Except that's an integer, so that's going to, oh no, hold on. Okay, at least there are no errors, right? Okay, so no errors, we got to assume it came out right. So traditionally, this is what people did. We still have the idea of nesting down here. That's still critical, but we really don't need the range if we go for row in grades and then we go for grade in row. We can print the grade as opposed to having to print grades with a specific index. So that's 2 ways of doing it. Still a bit ugly, right? It works, but it's a bit ugly. So let's see what we can do about that. Let's see if we can, well, let's work with this one. After each grade, instead of going to a new line, let's just skip a space. After each row, let's skip a line. And let's see what we got if we do that. Okay, so now we have something like this. And that basically makes sure that we're still in the right order. Okay, so that basically recreated our data in a human readable form. What did we do? We said, okay, after every grade, don't go to the next line, just print a space. But after every row, skip a blank line. We can do exactly the same thing up here. And there's a space. And this is where you see how important the indentation is. This print happened, and actually, let's put another print here to separate the two. This print, you have to notice, is outside of the inner loop. So this inner loop finishes before it hits the print. And this print is outside of both loops. So when we do that, we see a nice 2 sections that are the same. So my preference is for not using indexes. And I don't need to if I think about this 2-dimensionally. So that's a preference. If you're not comfortable with how this works, you can go back to a more traditional approach of using range, doing it this way. As a matter of fact, I could find out these numbers 3 and 4 here are not magic. I could figure those out. And maybe we'll try one more time since we're running out of time. And we'll put a print over here. Okay. So where can I get the number 3 from? I can get the number 3 from length of grades, right? There are 3 things in grades. That's the number 3. Well, where can I get the number 4 from? Well, that's trickier, and that's actually an assumption that each of these has 4 items in it. And that's a song for another day about what are we going to do if there's data missing. But let's assume that this thing is a perfect rectangle of 3 by 4. Where can I get the number 4 from? Well, I need to take the length of something. And I could take the length, since they're all the same, of grades 0. And what am I missing here? Missing a closed parentheses. How do I know I'm missing a closed parentheses? Well, this matches to this. I forgot the closed for that. Again, PyCharm's there to help you. So assuming that your data is a pure rectangle, then you could still use this, but the advantage is you don't need the 3 and the 4, which is an advantage. The disadvantage is it takes a lot of typing. And furthermore, you can do this, and this would actually support a different number in each row. I guess I should test that. we take out the 85 from here. See, that failed because of that number. So I can't fix it. You know, I've hard coded the 3 and 4 in here. I can't fix that. So that's a bunch of the considerations for how to deal with multiple dimensions. Now, the reality is there's nothing special about two-dimensional. We can create three-dimensional lists. There used to be an interesting exercise in, I think, the Programming 2 class, I think, on three-dimensional lists, which tended to give people a headache. And after that, you know, usually your mind just begins to get mushy about how to extend it beyond that. But if you if you write your lists to look like 2 dimensions, makes it easy. Now, the giveaway is there are 2 open parentheses here at the beginning and 2 here at the end. So if you're following this style, that's kind of a giveaway that it's a 2-dimensional list. And you can extend it if you want to. So this is your visualization. This is the old-fashioned way of printing them by hard coding 3 and 4 into here. This way, you don't need to hard code the 3 and 4. You can ask how many things are in grades, and assuming it's rectangular, I guess you could actually do row here. How many are in this row? Let's make sure that that works. Does. Yeah. So if you did it this way, you don't need to hard code the numbers in there, but you're still stuck with range statements. And now you have LEN statements. This way kind of covers everything with fewer words. So what's better? Well, I think that less is more. I think the fewer words and the fewer lines, the better off you are. So it's been proven over lots of years that the number of mistakes in a program is proportional to the number of lines of code. The more lines of code you have, the more mistakes there's going to be. The answer is fewer lines of code. The other answer is breaking your code up into functions so you can isolate these errors more quickly. And the others, of course, testing, and experience about how not to write code. All righty,
I do have a question.
go for it.
So I think I've duplicated the code that you've got here, but my display is coming out as a single column.
So the reason it's not is because of the end equals. Now notice there's a space in here, but that wouldn't do it. Does your print statement have end equals single space?
Let me double check. Apparently is where I missed it. Okay.
Okay,
Copy.
not a problem. All right, other questions? All right, so I'm going to